This is lesson 3, and what we're going to be looking at today are two different ideas with probability. Number one, the idea of the probability of at least one, and the other idea about conditional probabilities. We'll be looking at both these topics. The idea of at least one works because if you're looking at like this particular example, it says to find the probability that among 7 randomly selected graduates, at least one finds a job in his or her chosen field. Well, one way to do this is you could find the probability of 1, 2, 3, 4, 5, 6, 7, and then add them all together. Well, it's very time consuming, and if you were picking like 45, you wouldn't want to have to do that. So the easier way to do this is to use basically the complement rule is what you're going to be doing. Well, first of all, it says a study conducted at a certain college shows that 55% of the school's graduates find a job in their chosen field within a year after graduation. And again, the question reads, find the probability that among 7 randomly selected graduates, at least one, which you can't really see there in pink, finds a job in his or her chosen field within a year of graduating. It says, hint, you must use the 1 minus the probability of none formula. So I'm going to show you how to use that today. Okay, well, first of all, if we're going to think of the idea of the probability of none getting a job, then we have to figure out what's the probability of one person not getting a job. Well, if the probability of getting a job, they're saying is 0.55, they're saying 55%. Therefore, if you use the complement rule, the probability of not getting a job is 1 minus that, which is 0.45. Okay, that's probably of one person not getting a job. We're looking at 7 graduates. So you kind of think of this as the counting rule, which we'll talk about in the next lesson. But basically, the probability of the first person not getting a job is 0.45. Probability of the second person not getting a job is 0.45. Third person, 0.45, etc., all the way to the 7th person. So in essence, you're doing 0.45 to the 7th power. Okay, that's the probability of none of the 7 people getting a job. So if I want to figure out the probability of at least one, then I just need to subtract this off. So the formula is probability of at least one is 1 minus the probability of none. So we're going to do 1 minus 0.45 to the 7th power, because that's the probability of none of them finding a job. When you do this, you're going to get 0.996. So this is the probability of at least one finding a job, which is pretty good. Okay, that's the idea of at least one. And this particular formula only works for at least one. If you had at least 2 or something like that, it's not going to work the same way. Okay. The second topic that I want to talk about is the idea of conditional probability. Okay, I have this table here, and I can't see the whole table. But first let me talk about what the idea of conditional probability is. Conditional probability means that you're looking at a certain thing happening given that something else has already happened. So for example, formula is probability of A given that B has already happened. The way you find it is the probability of A and B, which again, if you remember, is an intersection where they overlap, divided by the probability of the second event, the one that has to already happen. It's given that B has already occurred. That's always your denominator. So if I was looking for the probability of B given A, this stays the same, but this would be probability of A. So whatever comes after this little bar is always your denominator. Okay? And we're going to be using this table. I'll kind of tally some things up for you. Basically, it's talking about the sexes of twins, and we're talking about identical twins and fraternal twins. And we've got boy, boy, 5, 5. Boy, girl, girl, boy, girl, girl. Basically, identical twins, there's 10. Fraternal twins, there's 20, for a total sample size of 30. So that's going to be my denominator in both of these events that we're going to be looking at today. Okay, this is the question. It says, after studying the sonogram more closely, the physician tells the pregnant woman that she will give birth to twin boys. Very important here. Say I'm telling her she's going to have boys, twin boys. Okay. Question is, what is the probability that she will have identical twins? That is, this is what they want you to find. Find the probability of identical twins given that the twins consist of 2 boys. Well, these are my 2 events. I'm going to call identical twins event A and consisting of 2 boys event B. Okay, so that's what I'm going to look at with this. Alright, so what we're going to do is we're going to first look at how we're going to set this up. So I'm looking for the probability of identical twins given that they're boys. Okay, so those are my two events. Well, let's look at the easier one first. Let's find the probability of being a boy. Alright, well if I look at that, go back to my little table for a minute. Okay, probability of being a boy, of all boys I should say. If you look, there's boy boy and there's boy boy. And I don't care about identical or fraternal right now. I'm just looking at the probability of getting two boys. Well, there's 5, 10, and it's going to be out of the total, which is 30. Okay, so event B, probability of getting a boy or two boys, is 10 out of 30. Okay. Now I'm going to look at the intersection, because remember the formula is going to be the probability of identical twins with the intersection of two boys divided by the probability of two boys. Okay, I just found out the probability of two boys. So the probability of identical twins and two boys, I'm going to look for where they overlap. Alright, going back to my table, remember these are my two boy categories. Well, I want to know which of these is where I have identical twins. Well, it's going to be this one. So it's 5 out of 30. That's your numerator. Notice when you do conditional probability, you're going to have a fraction over a fraction. Well, the good thing is they should be the same denominator. They're going to cancel out. And you're going to get 5 out of 10, which is 1/2, or 0.5. Okay, that's the idea of how conditional probability works.